Hi everyone, in this video we're going to be looking at molecular formulas versus empirical formulas. Now an empirical formula is the simplest whole number ratio of the elements in a compound, whereas the molecular formula is the actual number of atoms of each element in a compound. So first we're asked to determine the empirical formula for a compound with the following percent compositions: 40% carbon, 6.7% hydrogen, and 53.3% oxygen. So the first thing we want to do is consider these percent masses as actual masses in grams. So what we're going to do is we're going to take 40 grams of carbon, just like the 40% carbon, and divide it by its molar mass in order to get the moles of carbon. So we want to do this for each of these. So for carbon, we get 3.33 moles of carbon. We divide 6.7 grams of hydrogen by its molar mass, which is 1.008 grams, and we get 6.65 moles of hydrogen. And then we take 53.3% oxygen and divide that by its molar mass, which is 16, and we get 3.33 moles of oxygen as well. So next thing you want to do is you're going to want to divide each one of these by the least number of moles that were calculated. This will give you a molar ratio, which we can use to determine how many atoms are in this compound. So of course the least number of moles calculated was 3.33. So if we divide 3.33 by 3.33 in carbon, we get 1. Divide 6.65 by 3.33, we get about 1.99. We can round that to 2. Always try to round up to the nearest whole number. And of course, if we divide 3.33 by itself, we get 1. So these are our mole ratios. And what it's saying is we have 1 to 2 to 1. And what that's basically saying is we have 1 carbon, 2 hydrogens, and 1 oxygen. And we can use this for our empirical formula. We can say that we have C, H2, and O. Okay, next we're asked, a major textile dye manufacturer developed a new yellow dye. The dye has a percent mass composition of 75.95% carbon, 17.72% nitrogen, and 6.33% hydrogen by mass, with a molar mass of about 240 grams per mole. Find the molecular formula. So we want to do the exact same thing here as finding the empirical formula in order to get the molecular formula. So what we're going to do is we're just going to take these masses and divide them by their molar masses and get the number of moles. So carbon would have 6.32 moles. If we take 6.33 grams of hydrogen and divide it by its molar mass, which again is 1.008 grams, we get 6.28 moles of hydrogen. And then we'll take the 17.72 grams of nitrogen, divide that by its molar mass, which is 14.01 grams, and we get 1.26 moles of nitrogen. And just like last time, we want to divide each one of these by the least number of moles that was calculated, which was in this case 1.26. So if we divide the first one by 1.26, we get about 5. And that's for carbon. If we divide the second one, which is hydrogen, by 1.26, we also get about 5. And finally, if we divide 1.26 by itself, we get 1. Okay, so now we have the mole ratio once again. So we have 5 to 5 to 1. And what that is telling us is that in the empirical formula, there's 5 carbons, 5 hydrogens, and 1 nitrogen. So the empirical formula here is going to be C5 there we go, C5, H5, and N. But we're asked to find the molecular formula, which is different from the empirical formula. And to do that, what we want to do is divide the molar masses by each other. So we were given a molar mass of 240 grams per mole, and that's for the actual compound. But our empirical formula here isn't the actual compound. It has a different molar mass. The molar mass in this case is going to be 79.09 grams. 79.09 grams. And what we can do is we can take the molar mass of the actual compound and divide it by the empirical formula molar mass. So we take 240 grams per mole and divide that by 79.09 grams. And we get about 3 with our answer. So what can we do with this 3? Well, if we take it and multiply it by our empirical formula, we can change the number of atoms in each element. So instead of C5, we'll have C15. Instead of H5, we'll have H15, and N will have 3. And this is our final answer. This is the molecular formula. So to wrap it up, basically all you need to do to find the molecular formula is find the empirical formula, and then divide the actual molar mass by the empirical formula molar mass, and then multiply that to get your final answer.